Today we're going to be moving on with our rational functions unit and learning about horizontal asymptotes. So similar to our vertical asymptotes, we're looking at when something goes to infinity or negative infinity. But yesterday we were looking at what happens when f of x goes to infinity or negative infinity. When it's a horizontal asymptote, now your x is what's going to infinity or negative infinity, and you're looking for what number y approaches. So let's take a look at this first function right here. So notice your x's are now what's going towards, in this case, negative infinity. Whereas my f of x, or my y value, it's getting closer and closer to 0. In this table, again, my x's are getting bigger and bigger positively, so my x is going towards infinity. Whereas my f of x is getting closer and closer to, again, 0. So since my x is going to infinity or negative infinity, my horizontal asymptote is y equals 0. So a horizontal asymptote is always going to be y equals, whereas a vertical asymptote was x equals. Let's look at a couple other examples. So if we look at this problem right here, number 2, this is my function I'm starting off with. This is my table. So I'm looking at my x's. X's is getting bigger and bigger, but negatively, so this is going towards negative infinity. What is my y approaching? 0. And for this table, as x gets bigger and bigger, so this time it's going towards positive infinity. What is my y approaching? Again, 0. And now we're going to write this in proper rational form and compare our results. So proper form is when we're trying to divide 3 divided by x plus 2. But in this case, we actually can't do this. Like, you can't divide 3 divided by x. It's going to give you 0. Because this is already in proper form. Because for a proper form, we want our numerator, the degree of the numerator, to be smaller than the degree of the denominator. So this one's already in proper rational form, so 3 over x plus 2. So from our tables, we figured out as x goes to infinity or negative infinity, y approaches, or f of x approaches 0. And so our conclusion is that since your x is going to infinities, your y approaches 0, that means we have a horizontal asymptote at y equals 0. Okay, let's look at number 3. So again, let's look at our x's first. So as x approaches, what is this getting closer and closer to? Negative infinity. F of x, or y, is getting closer and closer to, let's look at these numbers now, 3. For this table, x is approaching positive infinity, and y, or f of x, is approaching, again, 3. So we already know here that as x approaches infinity or negative infinity, y is going to approach 3, which tells us that we have a horizontal asymptote at y equals 3. So again, our horizontal asymptotes are when y equals a number, x is approaching infinity. Vertical asymptotes is when y approaches infinity, what x is approaching. So again, we're going to rewrite this in proper form. So we're going to do 3x, and we're going to add the plus 0 here because it's missing the constant. And over here you have x plus 2. So let's divide our first term, 3x divided by x. So in this case, we can actually divide this because the x's cancel out. This leaves you with 3. So we're going to put a 3 on top, and we're going to multiply 3 times x, which gives you 3x, and then 3 times 2, which gives us positive 6. And again, please don't forget the very important next step here, which is changing the sign. So I'm going to even do this in a different color. So this is going to become negative. This one's also going to become negative. So 3x and negative 3x cancel out. 0 plus negative 6 gives you negative 6. We can't divide negative 6 by x, so we're done. So my proper form here is my answer, which is 3, plus my remainder, which is negative 6, over my original denominator, because what your remainder is going to stay in your fraction. So looking at comparing your proper form to your horizontal asymptote, you should already see a connection that we're going to make clear in a second. Okay, one more quick example using tables, and then we'll go into the rule. So let's look at number 4 now. as x approaches negative infinity, what is f of x approaching? So look at these numbers. It's getting bigger and bigger negatively. So this is actually approaching negative infinity. As x approaches, your x is getting bigger and bigger, positive infinity. F of x approaches. F of x is also getting bigger and bigger, positive infinity as well. So, as x approaches infinity or negative infinity, f of x is also approaching infinity or negative infinity. What does this tell you? There's no horizontal asymptote, right? Because it has to approach a number for it to be a horizontal asymptote. Let's look at what this looks like if we try to write it in proper form. So we have 3x squared is going to go inside of our division house. It's clearly missing some placement zeros, placeholder zeros. So we have 3x squared plus 0x plus 0. And we're dividing it by x plus 2. So we have 3x squared divided by x. First term divided by first term. This leaves me with 3x. So I'm going to put that right here. Multiply 3x times x gives me 3x squared. 3x times 2 gives me plus 6x. Very important next step, change the sign so these both become negative. So 3x squared minus 3x squared cancels out, 0 plus negative 6, negative 6x. Bring down the plus 0, repeat. So now we have negative 6x divided by x, which gives us negative 6. This is a negative 6 up here, so negative 6 times x, negative 6x. Negative 6 times 2 becomes negative 12. And again, very important next step, change your signs. So this time both of these are going to become positive. Right. And so negative 6, positive 6 cancel out. 0 plus 12 gives me 12. I can't do 12 divided by x, so this is my remainder. So my proper form is 3x minus 6 plus my remainder 12 over x plus 2. So, looking at these four examples that we've just done, now we can talk about how we find our end behavior, which is our horizontal asymptotes for rational functions. So what happens when you go to the left and the right of rational functions? So we can find our horizontal asymptotes by converting our function to proper form. So if we write proper form as f of x equals g of x, so this is our answer, plus this is our remainder up here, and this was our original denominator. Right, so it's in proper form when the degree of the numerator is now less than the degree of the denominator. So when x approaches infinity or negative infinity, the fraction part of this is always going to go to 0. So what's left over is the g of x. So notice how for number 3 here, if you look over here, if the negative 6 over x plus 2 goes to 0, that just goes away. What's left over is the 3. That is your horizontal asymptote. Right? For number 2, if the fraction part goes away, there's nothing left over, so your horizontal asymptote is y equals 0. For number 4, when the fraction part goes away, you're still left with 3x minus 6, and that's not a number, so you cannot have a horizontal asymptote. Okay, let's try to do a couple of examples now. Flip the page. Let's look at number 5. So first thing we want to do is put this into proper form. So if we're trying to divide negative 4 divided by 2x plus 1, can we divide negative 4 by 2x? No, we can't. This degree is already smaller than this one. So this is already in proper form. So f of x equals negative 4 over 2x plus 1. Like we just talked about, the fraction part of this, when x is going to infinity or negative infinity, this whole thing goes to 0. So if this whole thing goes to 0, my horizontal asymptote is just y equals 0. Let's look at number 6. So for number 6, again, if I'm trying to divide to put it into proper form, can I divide x by x squared? No. Again, my degree on top is already smaller than my degree on bottom. This is, again, already in proper form. So my proper form is my original function. And again, the fraction part goes to 0. So if this goes to 0, what's left over? Nothing. My horizontal asymptote is, again, y equals 0. Because because that whole thing goes to 0. Let's look at a couple different examples now. So for number 7, don't get confused by this. If you look at the numerator here, this is currently not in order. The 1 comes before the negative 4x. But x should technically come before 1. So we're going to rewrite this as negative 4x plus 1, because the 1 is actually positive. The negative goes with the 4. The bottom is already in order. And now we can divide. So we have negative 4x plus 1 divided by 2x plus 3. No placeholders. So we have negative 4x divided by 2x. The x's cancel out. Negative 4 divided by 2 is just negative 2. We can put the negative 2 on top. And we can multiply negative 2 times 2x, negative 4x. Negative 2 times 3 is negative 6. Again, our very important next step, change the signs. So now they're both plus. So this cancels out. 1 plus 6 gives me 7, so that's my remainder. I can't do 7 divided by 2x. So that's as far as I can go. So in proper form, f of x equals my answer, which is negative 2, plus my remainder, 7 over 2x plus 3, my original denominator. So just like with these two problems up here, the fraction part of this goes to 0. So if this fraction part goes to 0, what's left over? It's just a number. So my horizontal asymptote is y equals negative 2. Okay, one last example like this. So again, we're going to divide. This is already in order. I have x squared plus 2x plus 1. It's not missing anything. By x minus 2. So let's divide x squared by x. X squared divided by x gives me x. So I'm going to put x right above my 2x, lining it up. X times x, x squared. X times negative 2 is negative 2x. Again, very important next step. Change the signs. These two cancel out. This is positive 2 plus 2x. So this gives me 4x. Bring down the plus 1. Repeat. 4x divided by x gives me 4, because the x's cancel out. So I'm going to put plus 4 up here. Multiply 4 times x, 4x. 4 times negative 2, negative 8. Again, change the signs. 4x and the negative 4x cancel out. 1 plus 8 gives me 9. I cannot do 9 divided by x, so this is my remainder. Let me write my proper form. So proper form, I have the answer, x plus 4 plus my remainder, which is 9, divided by x minus 2, the original denominator. So just like before, the fraction part goes to 0. But what am I left with here? I'm left with x plus 4. Is this a number? No, it's not. You have an x in there. It's not just one number. So we're not going to have a horizontal asymptote at all, because it doesn't leave us with a number. It leaves us with x. Right, and so we know x is going to go to infinity. So no horizontal asymptote if it leaves you with not a number. Okay, so now we're going to put this together with what we learned yesterday. And for each problem, we're now going to determine the domain, vertical asymptote, and horizontal asymptote for each of these rational functions. So let's start off with number 9 here. So for our domain, we're just looking at the denominator. We're saying x squared plus 1 does not equal 0. Again, this is not difference of squares. This is not a difference because it's plus, not a minus. So if we were to try to solve this, we would end up with the square root of negative 1. Can you take the square root of a negative number? No. So there's no solution, which tells me my domain could be any number, all real numbers. By vertical asymptote, there are none. For my horizontal asymptote, this is what we just did now. So if we try to divide x squared, it's missing a 0x plus 1. Can we divide 4 by x squared? No, we can't. It's already in proper form. Right, so if it's already in proper form, 4 over x squared plus 1. the fraction goes to 0. So what is my horizontal asymptote? It's y equals 0. So whenever it's already in proper form, your horizontal asymptote is y equals 0 because that fraction is going to go to 0. Okay, let's look at number 10 now. Again, denominator cannot be equal to 0 for my domain. So x plus 1 cannot equal 0. Solve for x. X cannot equal -1. That's my domain. If I know my domain, I know my vertical asymptote. X equals -1. And now for my horizontal asymptote, that's what we just did today, we're going to be dividing 3x plus 1 divided by x plus 1. So 3x divided by x, we can do that. It just gives us 3. We're going to put a 3 up here. 3 times x is 3x. 3 times 1 is plus 3. Very important next step, change the signs. So they both become negative. And this gives us, these cancel out, 1 and -3 give us -2. So we know that in proper form, this is our answer, 3 minus 2 over our original denominator. So we already know this fraction goes to 0, so what does this leave you with? Just the 3. So your horizontal asymptote is just y equals 3. So you also could have written here, instead of a minus, you could put plus negative like that. They mean the same exact thing. Okay, one last problem. Again, let's start off with domain. Denominator cannot equal 0. So we get x does not equal -4. That's my domain. Once you know your domain, you know your vertical asymptote. X equals -4. For our horizontal asymptote, again, we're going to use long division. So for this one, be careful. We have 2x squared. This is missing a term. So you need a placeholder 0 for the 0x minus 1 divided by x plus 4. So the numerator always goes inside of the division house. 2x squared divided by x. This gives us 2x. That goes on top. Let's multiply 2x times x. 2x squared. 2x times 4 plus 8x. Again, change the signs. So both of these are going to become negative. These cancel out. We end up with -8x. Bring down the -1. So now we're repeating -8x divided by x gives you -8. So this is a -8 up here. -8 times x is -8x. -8 times +4 gives me -32. Again, change the signs so they both turn positive. -8 plus 8 cancels out. -1 plus 32 leaves me with -31. So in proper form, this equation is 2x minus 8 plus -31 over x plus 4. So when this fraction goes to 0, I'm left with 2x minus 8. Is this a number? No, there's an x in it, right? So is there a horizontal asymptote? There is not one, because if there's an x left over in my answer, I cannot have a horizontal asymptote. Whereas for number 10, there was only a 3, so that was my horizontal asymptote.